Hey, we're going to go ahead and get started here. Thank you guys so much. Everybody's checked in, or everybody knows how to check in. We are going to have our presentation today kicking off the polypropylene section of our breakouts. Success stories converting traditional materials to polypropylene. And I've got my clicker. Is it working? Oh, that's my background music. And I believe that's the hotel. What's that? Yeah, same. There we go. So, hey, it was Ralph Waldo Emerson at some point in time in the late 19th century said, build a better mousetrap and the world will beat a path to your door, right? And when you think about what we talked about earlier, Art McElroy always said there had to be a better way. And when you think about McElroy and the way we put things together, we like to call finding a better way the McElroy advantage. You know, whether it's trying to find the best way for someone to go on the job site and get overhead in a tight place with a lighter piece of machinery, or a way to have machines that can give you more productivity on the ground. We always want to find that better way, that McElroy advantage. Another McElroy advantage could be considered, a tech team that's there to answer your questions every day from 8 to 5 and help you through troubleshooting, or an inside sales team that's there to help you through pricing and lead times and that type of thing. Or our training, that's another McElroy advantage. But we're always looking out for something with a McElroy advantage. That's just in our nature, right? And this kind of carries along with the thing we talked about all morning long is, what's your purpose? We like to look at what we do as making the world a better place through better infrastructure, whether it's in the ground, in the building, or around the world, right? And we're talking about change. And Dr. Mark this morning talked about how change is a transition. And we all deal with that every day, especially in polypropylene. Polypropylene right now is where polyethylene was probably 30 years ago. Still an emerging market. We're still trying to affect that change. We're a blip on the radar for that type of piping in the pipe, valve, and fitting, and the plumbing, and the HVAC market. So how do we change that paradigm? And that's really, we really want to talk about how we're going to provide some answers for you today based on some information we've taken in from some of our industry partners here. What you have to think about changing the paradigm is, what are the alternatives, why it's important, for the person or the ownership or the end user, why is that change going to be important to them? What's the real meaning that they're going to want to make the change? You want to get inside their head in a way to find out what's in it for them. Productivity, profitability, sustainability, these are all things that we hear that are very important. They talked about it this morning. Again, sustainability is a big thing. It's something that is creating change, and we want to change the paradigm. All of these things are going to make the world a better place. And that's the purpose that you have in the marketplace, to go out and help make that happen. So you think about things that change the world for the better. And one example I think of, maybe the oldest thing outside of creating fire was to make the world a better place, was the invention of the wheel, right? Can you imagine the first caveman who thought, hey, we don't have to carry these things. We don't have to get 5 or 6 guys to carry things. Let's build a platform. He probably didn't speak like that. He probably, there's some sort of different language, right? But in my mind, he speaks English. And so, but he's talking about, hey, we could round out one of these stones and maybe put a hole through it and get some wood and go through, and maybe we can start putting platforms on this stuff and we can start rolling it around and just make it easier. And then the next guy, maybe, I don't know, this looks like it's probably sometime, I'm not good at history, but, later on down the road, maybe BC at some point, where they're like, now we've got the concept of the wheel, but how are we going to go over these cobblestone roads or anything that we made? We're going to make some steel. That's a natural resource that we found, and we can mold it into something and put it around this wooden wheel. Now, this wooden wheel is kind of heavy, but thank goodness it's not as heavy as that stone. And then later on, the wagon wheels that come along, they're much lighter, they're easier to use. They might break, but eventually you start getting into motor cars. And, we can't use these big wooden wheels there because as you're driving faster, you're going to break the wood easier. We need something that's going to be lighter and more effective. But the tubes are going to pop so much until they finally get into the radial tire. An invention like this that evolved made the world a better place. And that's what we want to talk about today. And today, how to make the world a better place, and how we encourage those people who own projects or the decision makers for those projects, how to encourage them to make those decisions. And normally we come in and we give you a conversation about how our tools make a project more productive, how our tools can be more conducive to the job site conditions. And today's really not about that. Today is really going to be about what the pipe is and what the pipe can do. It's something different. And after I talked to several of our pipe partners saying, hey, this is a presentation that I really want to do to talk about gravity, to talk about how do we go in, how does one go in and make that change to make the project better, more sustainable, more profitable, and what's in it for those folks out there in the field. How do we do that? And that's me talking about the pipe, because the pipe goes first. The pipe decision goes in first, and then the tools, which are a very important part of the process, the tools come later. So how do we do that? And I want you to think about the perspectives that we're going to be talking about today, because everybody in this room might have a different perspective. There's the machine manufacturer, right? My perspective, or anybody's in one of these green shirts today, our perspective as the machine manufacturer on how to change that paradigm is we want to help in any way we can. When you're going in and trying to affect a specification in any way, shape, or form, we want to be there and help if we can. Does that mean you want us to help write a spec to present, to have a certain type of machine go on there, or the use of a data logger? We can be there to help. All you want us to. But at the end of the day, we're still going in with you there because the pipe is a specified product and the decision's there. From a pipe manufacturer standpoint, you guys have told us the stories for years about, hey, there are choices like A, B, C, and D, and these are the features and these are the benefits, and this is why this system is going to be better for you in the long run. And that's what this presentation today is going to be about. It's going to touch on some of those things. So that's the pipe manufacturer's perspective of where it's going from there. And then a distributor or wholesaler perspective is going to be a combination of the two, right? Because a lot of distributors, they partner with their manufacturer's rep or their pipe company rep and their tool manufacturer to do all these things, or they might have their own specification team to go out and still try to make those decisions too. So the perspective from them is, what resources can you give me, Mr. Manufacturer, that I can help go out and affect that change? A rep firm the same way. And a lot of the rep firms are going to be more focused on that specification change with their relationships with contractors, and they can go introduce that opportunity to the contractor, but they're going to be thinking of it in a very similar fashion as the distributor. Where are those opportunities, and where can I go help, and what are the points that I need to make? And the points that you need to make are what we're going to talk about here. And then the contractor just says, the contractor either says, I'm all in, or hey, I'm not going to do that because I'm used to doing welded steel and I'm not going to change. But you have to understand where the best benefit's going to be for the contractor. But in this decision, it's going to be with the decision maker of the project itself. So I just wanted to kind of give you, depending on where you sit in the room, those are some of the perspectives, and you might have a completely different take than that. And please, as I go through these projects, I've got 5 projects I'm going to share some small details with you about on how change was affected to put polypropylene on these projects. Anybody in the room that has had any involvement with any of these projects, please feel free to add any type of color you want when we get to the Q&A session, because I want to make sure I do all these projects justice so you guys feel that you know the right things were talked about on how this was affected. So the last perspective is really the project owner or decision maker, right? And outside of everybody here, this is the person that you need to get to. And it could be a design build firm, it could be an engineer that's been giving carte blanche decision-making power over how they're going to do something. It could be the owner of the facility itself. This is the person, and their perspective is going to say, what's in it for me? You know, what was it on Dr. Mark's presentation today? He actually had WeFM. What's in it for me? That's exactly what I love it whenever these guys come in and they do their keynotes and they actually are talking about things that are in my presentation later that I'm just like, check right there. So anyway, and I think you guys are going to be really excited about this presentation because, and this is a true story, as I went through my 2 presentations that I'm doing this week, I did them yesterday at my house on my screen. After we set up for the product showcase, I went home, got cleaned up, put them on my big screen, and just started walking through it. And about halfway through the first one, I realized that my dog, my 95-pound Shepweiler, was sitting on my couch, like sitting up, looking at me like this the whole time, very intently, listening very intently. And he did it the entire time through all the times I did the presentations. And he sent me a PO this morning, so it was great. The presentation's already done its job, so I just hope you are enthusiastic as Harry Carey, my Shepweiler. Anyway, so the first project I want to talk about, this was an article that was published for PPI, by PPI. Deanne Hughes was a part of that. And is Deanne in here? I thought I saw her peek her head in. And Steve Sandstrom, I believe, those were the 2 that published this article for PPI. And I believe it's over in Europe. It's a university hydronic system project. And for some reason, I feel like more comfortable over on this side of the podium as I look at the picture. So the project itself was specified for 6-inch Schedule 40 steel with 2 inches of fiberglass insulation and an HDPE jacket.
That's it.
Oh, there we go. So let's take a look at this picture right here. I'll get a big view of it. So you've got your steel, your black steel. Well, it looks more black over here. Over here, it's already resting, and I've got a comment about that. And then you got your insulation, and then you got your HDPE outer cover. Now, people always talk about, as soon as steel is installed, it starts to corrode. And that's not true. As soon as steel is created, it begins to corrode, okay? As seen here, because this is not installed yet, and it's already corroding. And then just think about the corrosion and the loss of flow with tuberculation later on down the road. It's just not a good thing. But that's beside the point. I just wanted to show you the sample of this particular type of pipe that they were looking to specify here. Now, I want to go back to this slide. Polypropylene was a specified alternate. Now I want you to think about that. Whether or not it was a specified alternate from a pipe company that went in and asked them to change it for this project, or whether it was someone that went in and talked with an engineer or decision maker at another time to talk about polypropylene and its benefits, and that particular decision maker added it as an alternate, at some point in time, someone had to go in and have that conversation, because Schedule 40 steel pipe with 2 inches of insulation and an HDPE jacket was the norm. It was the traditional specification for that type of project. So at some point, someone had to go in and present the reasons why polypropylene would be a more effective choice. And you'll see as an alternate spec on a couple of these projects that we talk about here. So keep that in mind. And there's the big picture of the OE pipe. And so back here to the hydronic project. This is what was at the top of the mind of the decision makers for this project, okay? This is an extension to a new sustainability technology center, okay? So sustainability, it's a big topic. It's always a big topic. People wanting to reduce their carbon footprint, and in this particular case, they had a goal on campus to reach a carbon neutrality by 2050. So in building this extension from the current condenser system over to a new building, they wanted to make sure that they were going to have something in place that is going to be abide by the goal that they have set for this project, or for their big picture overview for the university of reducing the carbon footprint. And it happens to be for their Institute for Sustainability, Energy, and Environment. So it's very important to them, obviously. Green ideas and green concepts are not going away. So it's very important to utilize this as a tool in your toolbox to help make those decisions for the decision makers, because it's here to stay, and we're going to continue to see that as we move forward. Other concerns that were on the top of their mind, the direct burial that they had planned for this particular project would disrupt the entire landscape and structures. They knew that there would be additional costs for the equipment, and they knew it would displace a lot of the parking and a lot of the students and a lot of the faculty on how they get there. So imagine if you are going to work every day in a certain way, and you have a parking lot that you get to, you have certain side streets that you drive down to get to that, how much disruption you would have in a campus of, say, 10,000 or 20,000 students with faculty of around 200 or 300, disrupting that and trying to reposition those folks into different places to make sure that they can get to class. That's a big disruption, and they were worried about all these things. Plus, on top of it, to actually have to make that type of commitment to going in and doing a direct bury, you're dealing with a lot of extra equipment and fees that go along with that equipment. So the alternative was proposed to go ahead and do a partial, or to do either polypropylene in a horizontal directional drill, or do the direct bury with the steel pipe. And they started to realize we could reduce the footage and the fittings and things like that on the polypropylene by going to HDD, because we can go more of a direct shot. And we're not going to disrupt the entire campus like we would by going direct bury. And reducing costs was very important to them. So the solution was, they didn't go fully polypropylene, but what they did do is they went partial polypropylene with the HDD, and then direct bury with some of the steel pipe that was already rusting that I showed you earlier. And this was able to create a solution for them on campus to meet the standards that they wanted to meet for the project. And this is an example of the insulated pipe, and it's polypropylene on the outside and on the inside with insulation in the middle. So, very good concept. Sorry I don't have a better picture of that, but I blew that up from the publication that I was able to get from our PPI friends. So the takeaways from this, when we got into the mindset of the owner and what they needed, which in this case is the university, the takeaways, reducing costs was on the top of their mind, right? Eliminating campus disruption was very important to them. Mitigating the landscape damage was important to them, because when you think about those costs again, not just the cost of renting the equipment and moving the dirt, but whenever you have to replace all that and then redo the landscape, that was a big cost. And then meeting the sustainability goal, which is part of a carbon footprint big picture item that they're looking at for the entirety of the next 30 years. So these are the takeaways. These are the things that really resonated with the ownership. And we're going to add these takeaways to a list that we're going to review later as part of the tools in your tool bag to be able to pull out whenever you're meeting with those decision makers to help them determine whether or not this is a good choice for them, which we know it is. So on this particular project, it's a data center with a chiller system for a data center, and it was specified for 2-inch up to 18-inch steel pipe. And polypropylene was an approved alternate spec. Now, think about this again. At some point in time, someone had to go in and get this specified. Whether it was for this specific project or a project before that, someone had to make that decision, because the traditional piping was obviously steel pipe. And when you think about data centers, we talked about, this morning we talked about the vault. That data has to go somewhere. You all have emails. You have personal emails, you have work emails. That data has to be stored somewhere. Everything on Amazon has to be stored somewhere. Everything on your Instagram or Facebook or anything like that has to be stored somewhere. Right? Data centers are lifeblood. All your banking information, that's stored somewhere in a data center. So it's really important to have an operating system for any type of water that's going through the facility to prevent damage to that, so you don't lose information, especially if it's banking information, because that would not be good. So top of mind for this particular project, for this ownership, was the construction schedule, okay? They wanted to make sure that they were going to stay on time, because they had several different buildings they wanted to focus on. They wanted to make sure that that was something that could be accommodated to them, to make sure they weren't going to have to wait for anything. Guarantee of workmanship, okay? The pipe partners that we have are great. I mean, people have warranties and things like that, but also if there's anything that is prefabricated, they want to make sure there's protection on that workmanship too. So that was the top of mind for this particular group before they would change the specification. And then maintenance. how many times over the next few years are we going to have to change this out? And what are we going to have to do? What type of chemicals do we have to put in the system to prevent any type of corrosion or damage or tuberculation to reduce that over its lifetime? So for this particular project, these were three things that were very much top of their mind. And other concerns that they brought up were safety issues. First, during the installation, moving stuff around, safety becomes a bigger concern on every job site. I know some companies have a safety minute of every day before they even start the day. They want to make sure that they're going to have a safe working environment, and how could polypropylene be a safer product for them than others? And then how is a heavy duty piece of piping going to be on the structure of the building versus polypropylene? What would that look like? Would it provide more stress to the building as opposed to less stress to the building? And then the life of the pipe, which you talk about the maintenance, how often are we going to have to replace it? That's when we're talking about total cost of ownership. And I'm not talking about total cost of ownership of how much is your building, okay? I'm talking about, here's our installation price today on polypropylene, here's our installation price today on steel, and then how much does it cost for the maintenance of those systems to prevent corrosion and damage and replacement, and then how much is, how often are you going to have to replace that? Well, on polypropylene, the life of the building is probably the life of the product, and unless it's 300 years from now, I don't know, who knows. But on steel, every 10 to 20 years, there's going to be a replacement of the system. Every 10 to 20 years. So let's just say it's 30 years. You're reinstalling that every 30 years, in addition to the maintenance and the repair that you have to do to it as it corrodes. That's your total cost of ownership. So how much does that cost in your mind versus the polypropylene, changing to the polypropylene? Again, all things in the top of the mind, what's in it for me, the owner, those are the things we're talking about. Well, so the solution to all their concerns first was prefabrication and time deliveries. So the result was, hey, your construction job is going to be based in quadrants, right? You're going to have 4 different timelines of 4 different buildings. We're going to time these deliveries out, and we're going to prefab it to make sure it's delivered. This section is delivered at the right time for each one of these projects. So you're not going to, or each one of these buildings. So you're not going to have to worry about that. We're going to make sure the timeline's right, and you're not going to worry about things being slowed down. A weld warranty as well as a product warranty. Anything that we prefabricate, we're going to have a warranty on, so you don't have to worry about that. And then of course the product for qualified installers is going to have its own warranty as well. So those are things that immediately take away the concerns for the owner on this job. It's lightweight, which is great because it's not going to be as dangerous as carting around steel on a job site. And it's also going to put less of a burden on the structure itself because it is 20% the weight of steel. All things on the top of the mind of the owners or decision makers, and it's going to be at a reduced cost. So all of these things very important. And as you can see here, here's just some pictures from this particular data center job. You see how items are coming up out of the ground when they installed in the ground, and then when the prefabricated products came in, they would be attached to these areas like that. So if you look at the takeaways here, eliminated job site disruption. What was the job site disruption on this one? Well, it was the timing of each building and potentially delaying. No job site disruption because it was planned out nicely with the prefabrication plan. The warranties and the guaranteed prefabrication fittings, that all took away any concerns that they had there. Of course, lightweight, reduced cost. And they didn't say sustainable, but it's such a big subject. I threw sustainable on here because it's such a big subject. It's such a talking point now. This is what people are focused on. And we're talking about single use. People talk bad about plastics, right? There are single use plastics, and then there are plastics that are going to last a lifetime of a project, right? Plastic pipe is very important to our sustainability, so we don't have to replace natural resources over and over, because steel and copper and iron and those type of things, those are also natural resources that get corroded, and then there's no use for them later. Plastic piping is another natural resource, it's a byproduct of a natural resource that you're not gonna have to replace. So we can save these natural resources over here for other opportunities and other metallic needs that we have out in the marketplace somewhere else. So sustainability is going to be a talking point on every single one of these. Now, here's another chiller system. This is the third of my 5 projects that I'm gonna share with you here. And again, at the end when we have time for Q&A, there's some folks in the room that might have had something to do with some of these projects here, and I welcome any feedback that they want to give on any of these. But this particular project was a supermarket chain, and this was for a chiller and a refrigerant system, okay? So they were gonna work in combination together for both systems. It was specified stainless steel, and it's a master spec for a chain of grocery stores, and they were gonna do almost 20 sites in a region, some of them new build and some of them repiping systems, depending upon the situation. And we'll talk about why that situation came up here momentarily. Here was what was on the top of their mind. A dual purpose system, again, for refrigerant as well as a chiller system. And they needed to be very versatile, whatever piping system they were going to use, because they have a special glycol product that they needed to put in the system that could be able to handle both the refrigerant system as well as the chiller system. And they were worried about disrupting business during the day, right? It's a grocery store, so they're, whenever they open at 9 a.m. and they go to 10 p.m., they're going to have shoppers in there. So how are we going to be able to get this install done and not disrupt, what we're trying to do, and that's make money off selling food and goods, right? Other concerns was a failing system that would destroy equipment. Now that's very specific concern, right? And that's, I said earlier, I'll get to that in a minute. Their concern was a failing system that would not destroy their equipment, because they had a couple of failures where leakage of the leaking system got into their refrigerant system in an area like this, and in their freezers and refrigerators, and ruined all the equipment, right? So that would be where they had to repipe, just FYI. So that was a big concern. I put that in the other concerns area, but that was probably one of the main concerns, is we need a system that's not going to leak like this, because not only do we have to replace the piping, we have to replace all the refrigerant system and the coolers, and then the food that gets ruined. Sure, we might have insurance for that, but what about the lost time of selling other food while you have to replace the systems and get the new refrigerant systems in? All that is damaging to the bottom line. So the solutions, of course, the versatility of the system was the piping could obviously handle the right chemicals and products that were going into the system to do both the refrigerant and the chiller system in the same system. They worked days and nights, so during the day, they were doing things out of the way to try to get things accomplished, and then at night, they would come in and finish the things and do the things that they needed to do around where the shoppers would walk. And then the total cost of ownership was minimized, because you don't have to worry about replacing those things again later on. There's a nice picture of, I've already shown you pictures of chiller systems, so, I'll show you this. And plus, I'm going to show you another picture of a chiller system here momentarily. But this is the part of the system with the glycol going into the refrigerators. So takeaways: versatility, eliminated job site disruption, reduce the cost, and by the way, it's sustainable. So you can put that, I'm an environmentalist stamp right on that, because that's always going to be helpful from here on out. Now here's a great project, and it's a resort chiller that was specified 8 to 10 inch steel pipe, 3 brand new chillers on the rooftop of this resort. Now, this particular picture, this is the resort, this is where the chiller system was, and I took this picture from a helicopter off the coast of Maui, okay? So, and I got to see this. This is where the PPI conference was held in May, and so we were able to get a tour. Several of us at the conference were able to get a tour of this system, and it was really great to be able to get up there. And there's some, again, it's another chiller system, but there's different nuances that the ownership was concerned about that helped change their mind from going to steel to go to polypropylene. Salt spray gives rapid corrosion. So anytime you're within 20 miles of a coast, but you're especially on an island, salt spray is going to create rapid corrosion no matter what, okay? even if a system is coated, it is still going to create a rapid corrosion problem. Excessive heat. This particular resort is about 3 to 5 miles north of the Lahaina Old Town Village that was completely destroyed by the wildfires not too long ago, several weeks ago. And the term Lahaina in the, I don't know if it's the Hawaiian language, going way back, stands for merciless heat. So it gives you the type, it explains to you kind of a little bit of what you're looking at here, the type of heat that they're getting there. The resort was untouched. It did not get damaged at all. It was amazing how some of this stuff got damaged or did get damaged at all, and some just got completely wiped out. But maintenance was a big issue, and sustainability, not because I threw it in there, but because on the islands, sustainability is very big. In fact, the conference motto this year, the theme of this conference for the annual conference was sustainability this year. So in the islands, it's very important, and they want to meet sustainability standards when they do that. This is what was taken off of the old system that was installed about 10 years ago. So if you can see all that nastiness that's already been created inside, and you can see down here, that's not great. And that's pretty rapid corrosion for a system. That's very young in the age of the system itself to have to be replaced. So the takeaways here is obviously polypropylene was a great product to use to reduce excessive corrosion, rapid corrosion, and salt spray. And because of the coating that was on this pipe, which in some areas was painted, in some areas was coated, it was able to prevent UV rays from damaging the pipe and protects it from the heat. The maintenance, obviously, the maintenance is very low maintenance, unlike some of your significant others that you might have dealt with in the past. Low maintenance, and I said significant others because you go both ways, because some of you dudes out there are very high maintenance yourself. And then sustainability, because obviously it's a big issue. So, and going on to our last project here is a mixed-use high-rise. It's a hybrid air and HVAC system, 30-story high-rise. Okay, it's for cooling water tower, specified PEX and PTRCT. Specified specifically that for this project. Nearly 1,000 feet of PPRCT, and then there was like 150,000 feet of PEX, which was, that's a lot. I don't know if you've ever measured that, but that's a lot. So why did they spec PEX and PPRCT? Well, they knew going into it, they were able to prove to them on paper that there was going to be a 70% cost savings in how much they would spend on this project. And productivity and was a big factor, and prefabrication played a role in them being able to accomplish this 70% savings. They planned it out. They knew exactly what they needed to make and when they needed to make it, when they needed to deliver it, and when they needed to install it. All of this played a role in that savings. It's a corrosive-free product, and this particular project's in Florida. You know how humid and hot it can get and how tropical the weather is there. Corrosion can be an issue, so this was able to provide them a solution to have a corrosion-free product, and then low maintenance and no replacement, right? You don't have to worry about that corrosion making you create a total cost of ownership that's greater than necessary. Here's a picture of part of the install here. Again, reduce the cost, minimize job site disruption, corrosion-free, sustainable, and this particular project won PPI Project of the Year just this past year. So congratulations to those guys who put this project together. Now, here's the big picture takeaways. I told you I was going to take all the takeaways from each one of these projects and put them on a list to show you. I want you to know, these takeaways are not the only takeaways that you could have used to help change the paradigm and change what was going to be used on the project. These takeaways were just the ones that we talked about because those were the top of mind concerns of the ownership or the decision makers on the project. And that's why we're talking about these. There are dozens more reasons why you can change over to polypropylene and it would be a better benefit, but we reached in our tool bag or our industry partners reached into their tool bag and pulled out the things that were top of their mind and got on the agenda of each one of those decision makers to help them make that decision to go to polypropylene. Keep that in mind whenever you're out there. When you know what their concerns are, that's when you present what that tool is in your tool bag to show them how you're going to remove that concern. And if you stick with that, you don't just show up and throw up, and tell them everything the pipe does. Tell them what the pipe's going to do for them based on what their needs are. And in these particular cases, these were the needs that were part of the story that was told to each one of those guys. Was it on all 5 projects? It was corrosion free on all 5 of them, reduced the cost. All 5 of them eliminated job site disruption. All 5 sustainable. I took some liberties there because some of those weren't there, but it's true. They included those. Warranty on only one of them was warranty a real concern, but that was just on this project. Okay, warranty and guarantee of wealth, that was just on these particular projects we're talking about. Lightweight and safety, again, just on one of these we spoke of. Versatility and heat resistance. But when you think about it, every one of these projects could have had each one of these elements used to help that decision be made. So it's great to know that we've got guys out there that are fighting the good fight, trying to change metallics to plastics to make the world a better place, and know that each one of you guys in this room has a purpose out there to go out and try to make that change. And I appreciate everybody who provided the information for us to be able to go through this. And again, anybody that's been involved with any one of these projects, whether we talked about it or not before, you want to add any color to it, feel free. But with that, I'm finished, and I'm happy to take any questions that you might have.
Well, Jeff, I'll just like to point one thing out. When you do pipe sizing, let's say you have your 6-inch Schedule 40 steel line, it doesn't necessarily mean it's going to be a 6-inch polypropylene line.
True.
So,
Flow rating changes. Yeah.
because you're going to track up velocities because the metric system doesn't quite work that way. So it's not an even spot.
Sure, and that's going to be that conversation that's held between the pipe company and that decision maker at that time, depending on what they're looking for in their flow rating. You're not looking at 6-inch to 160 millimeter. You're looking at flow rating to flow rating.
Right.
So yeah.
Exactly.
So yes.
Do you have any experience of brownfield projects with polypropylene, especially when hot water is concerned? Have you guys got any experience with that at all?
I'm going to open up that question to my distributor and pipe industry partners that might have.
The question was, do you guys have any experience of replacing metals with polypropylene on brownfield existing hot water systems? The reason I ask for that is because, so in Canada, heat exchangers have copper-plated tubing, and so that polypropylene doesn't go well with that tubing. So we have to change the copper-plated tubing to nickel-plated before we use polypro. So I'm curious if you guys have ever encountered that problem before.
We have.
No.
We have. You guys have? Yeah. Okay.
It was expensive.
Okay. Right. That's the only one.
And
caveat
it's still
that I've got.
expensive.
So
We're not done.
for greenfield projects, it's fantastic because you have to specify nickel-plated heat exchangers.
Very valid point.
So that's, I'm just curious about brownfield specifically.
With
Yeah.
PPRCT, we've had an issue with copper.
You have not had issue with copper?
Yeah, that's what I was gonna say, why did that change the?
Because there are a couple of PPRCT who've had issues with copper ions specifically attacking.
There's a difference with PPR and PPRCT.
Okay.
There's two differences.
So I'd be interested to learn about kind of what those differences are.
Well, I think the important thing to point out there, right, is there's definitely this connection between copper. People always have that concern. Hey, can you install polypropylene and copper together, right? The real question is there going to be chlorine in the system, right? Because if there's no chlorine in your system, you can install them together any day of the week, whether it's PPR, PPRCT. You can run them at high temperatures, and you're not going to have any issues, right? Once you start introducing chlorine into the system, though, then those copper ions can catalyze that oxidative reaction between the two, right? So it's always important to point out that you need those three things there, right? You need chlorine, you need copper ions, and you need high temperatures for it to occur, right? And depending on the conditions of the system, right, you can get that oxidative reaction to happen to any polyolefin out there, not just polypropylene or PPR or PPRCT. It can happen, that reaction, it'll happen to rubbers, it'll happen to, PEX pipe, polyethylene, like whatever hydrocarbon out there, like you can get that reaction. So it's really important to evaluate the true conditions of the system and make sure it's being maintained properly, right?
It's about taking the copper out of its parameters,
Yeah.
like you say.
Yeah.
If you don't treat copper as specified for the basically Copper Institute, then you have that problem. About flow, velocity, temperature, chlorination.
But just further to that question, what is the catalytic reaction, what does that do to the, ultimately to the polypropylene?
So,
Or any oil?
yeah, so when you're so when the chlorine's in the water, right? Chlorine is an oxidizer, right? It's attacking whatever it can around that, and whether that means, stealing electrons from specific bonds or breaking bonds. In the case of polypropylene, what you see is you get a lot of chain scission, so it can actually break these long chains apart into shorter pieces.
Do you end up with a catastrophic failure? Or
Yeah,
crash?
well, it's not, I wouldn't call it catastrophic. So what ends up happening is that inside surface of the pipe oxidizes over time, and you get a lot of microfractures that occur systemically, right, throughout the pipe, right? And so, and then what happens is the pressure of the system itself begins to drive that fracture growth.
It propagates that?
Yeah, it propagates the fracture, and then you get pinhole leaks in the piping system. And then now you have to replace it, but then by the time you're getting those pinhole leaks, usually you have a much more system-wide problem that you're dealing with. Right? It's not something that typically happens in one spot unless there's some other reason for it, like some kind of surface concentration or other reason why that place might degrade prematurely.
And everybody wants to blame the PPR when in fact you took the copper out of its parameters again, which has caused the problem.
Yeah, the real problem is that copper eroding in the first place. Because if you don't have that copper erosion, it doesn't happen, right? So, yeah.
Good conversation. Yes.
Hey, so the refrigeration section of that, you happen to know what the refrigerant was? Was it CO2?
That was Dave Moore's project. He told me it was a glycol. It was a type of glycol.
Yeah, it's gonna have to be a glycol because normal refrigerants like Freons and stuff like that, and like the RXXX types, like they're not typically compatible with polypropylene.
Okay. I didn't realize that was one of yours. Thought. That's actually
Anybody else have anything they want to add? On any of the projects or any other questions? Or
I'd like to address what Brian was talking about here. So you were talking about how it's not like the diameter to the diameter thing isn't always a straight across thing. And yeah, you're right. Like we see that problem like on like 8 and 10 inch to the 200 and 250 millimeter is where we get that question the most, because that's where the ODs don't match most. Like there's the biggest difference. But I always like to point out, even though the diameters aren't the same, you can typically run higher flow rates in polypropylene materials than you can in steel, right? And so even though the ID on a polypropylene pipe is a little bit smaller than a comparable steel one, a lot of times you can do a diameter, like a direct diameter transition there, because you can run a little bit higher flow rates. The walls are smoother, and so you have, even though you're running a higher flow rate, you get similar or less head loss in the system overall. Right. So that's a really useful property of all the polypropylene manufacturers.
They also over-design a lot of the steel systems to accommodate for the corrosion to begin with.
Yep.
So
Yeah.
with the polypropylene, you could be starting in at a smaller diameter to
Yeah.
achieve the same thing.
Yep, that's a huge benefit, right? Is that like the ID that you start with on day one is the same at year 10 and year 50, right? And that's as compared to like that 3% loss in ID year over year with steel products. It's a huge difference once you get down the road, right?
and some steel projects, they'll flange it up and then they'll ask you to rotate it like every so often, so the corrosion in the bottom changes, and then the side is now the bottom, so it corrodes there, and there's I don't know, is that clockwise or counterclockwise? I don't know. That's irrelevant.
It's like, we don't deal with that, so.
So, anybody else have anything? Well, guys, thanks for being at this one. This was great. I was really excited about doing this one this year, and we've got some other great sessions that are going to be in this room. This is the polypropylene tract room. We've got later on, we've got Anthony Alvarez and Jesse Smith, right, talking about solutions to your maintenance and maintenance needs and things like that. Tomorrow, I believe, right after we get back from the product showcase, there will be one about training, and we'll have some great guest speakers from one of our industry partners, or a couple of our industry partners, along with Paul Brodsky. And then I'll close out tomorrow afternoon with some different ways to teach folks how to make some money on their tooling, whether it's small fabrication operation or a rental fleet. So if you guys have any other questions that you want to bring up, just come on up afterwards. We're excited that you're here, and thanks so much. We'll see you at the next session.